came into class like while you guys were going to the office. Like he just slept through the first hour on test day. And so then everyone's talking to me about the test, like Colton especially, and I kept saying, Colton, it's not taking the test. Let's stop talking about it. And then I was like, can you take it later when you're a TA? No, it didn't really work well for me. I said, okay, you're just going to take it during pre-calculus. Okay, no. That kid is ridiculous. You know, Miss Bai just requested new markers, and your mom just ordered a whole new set of markers. Why have I not done this? I know, it's more exciting to steal them. Okay, if you have these functions in the given domains and ranges, so the if part of these little properties are kind of important. If x is between -1 and 1, and if y is between -pi-halves and pi-halves, if you take the sine of arcsine or the arcsine of sine, does it make sense that the inverse and the function cancel itself out? Just like if you took the square root of x squared, because they're inverses, you just get x back. If you took the cube root of x and then you cubed it, right, they undo each other. That's kind of the definition of inverses, is that when you do the composition that you just get back the function. Why does one of them have x in them and one of them have y in it? Well, it depends on what's first, right? If they say the arcsine of x, remember that's going to be the value. If they have sine first, that's going to be the angle. And so that's why you won't have to figure that out. Like, it'll be written for you. But just don't assume that it always cancels out. We're going to do some examples in a minute. Because if they're outside the domain and range, you actually do have to think about it a little bit. But I just wrote these for all of them, right? Our cosine is stuck between -1 and 1 on the domain and 0 and pi on the range. And so again, if that's true, then they just cancel each other out. And look at this fancy little notation here, right? I've done this before in here, right? Written a little r like that. This means real numbers. I actually found the symbol for you so you can see like the typed version of that. But that just means x can be anything, right? X can be a real number because the domain of tangent, inverse tangent, is all real numbers. But we're restricted between -pi-halves and pi-halves. So what does this mean for problems? Let's move on because I didn't make you write any of this. Like this. On a test, let's say you forget what the restrictions are. You can work this out and think about what would I get if it's a value that we know. But if it's not a value that we know, then maybe you would want to think about the properties a little bit. But let's start with this. Inside first. This is what we did yesterday. What does this mean? Arcsine of 1. Yeah, that's like saying the sine of some angle equals 1, and you're supposed to tell me what angle that is. And what angle would that be? What angle has a sine of 1? Pi-halves. So this is like saying the sine of pi-halves. Because arcsine of 1 equals pi-halves. Start with the inside and work your way out. And what is the sine of pi-halves? Oh, it's 1. Right? So because 1 is in our restricted domain there, you could just say, oh, that just cancels out, and that just equals 1. You don't have to necessarily work it out because it's in the restricted one. What about something like this? 7 pi-halves. Is 7 pi-halves in our restricted thing for sine, or our cosine? No, so you have two options, okay? One option is we could just work this out. So let's do it like we did up here. Leave the outside one alone. What is the cosine of 7 pi-halves? Where is 7 pi-halves? It's definitely on here somewhere, right? And so you could just kind of add around. This is pi-halves. This is 3 pi-halves. Add again, that would be 5 pi-halves. That would be 7 pi-halves. So this is the same as 3 pi-halves or 7 pi-halves or negative pi-halves. Remember, one of the very first things we talked about in here with trig is you can just add and subtract 2 pi. That's how I get all those. So what is the cosine of that value there, down here? Cosine is x. What is x pointed down there? 0. And then what is the arc cosine of 0? That's saying what angle in the restricted range has a cosine of 0? You have to say pi-halves, right? Because remember with arc cosine, what are we restricted between? 0 and pi. So the only one that has a cosine of 0 is up here at pi halves. So you see how it doesn't just cancel out to give you 7 pi halves? Okay. I don't know if there's a better way to do that one, right? Just kind of work it out. That's okay. If you want to do that. What if I gave you, let's see, I might need to make my life work. Okay. What about this? What if I gave you, we're going to call this one 2a. 2b, I guess. That would be 2a. Arc cosine of pi fifths without a calculator. Pi fifths is not in my unit circle, right? So you have to think about, does that fit the restrictions? Can I say that arc cosine and cosine are going to just cancel out and give me pi fifths there? Is pi fifths in between 0 and pi? Yeah. And so that's where I could just say pi fifths. What about this one? Let me stick with cosine since we're close to stick. What if I said negative, I'm just going to think of something terrible, 13 pi over 40. Negative 13 pi over 40 is definitely not between 0 and pi. But what do I know about cosine? Cosine is what type of function? It's an even function. So if it's an even function, is it the same as if this said positive 13 pi over 40? So what if it said positive 13 pi over 40? Is that between 0 and pi, 13 pi over 40? So that would still be 13 pi over 40 because it's an even function. Oh man, that's crazy. What was that? Oh, your heart monitor. You give me every time. No, I just don't know what it is.
In the Paris meet last night, we were like all sitting there and talking about it, and like my thing started like really going off, and it's like loud, and it sounds like an alarm, and everyone just looked at me, and I'm like awkward, and I could literally write those notes and everything, and I had to leave because it kept going off.
Too much. Does that kind of make sense? Maybe this is something worth studying at some point in your life, right?
So that's all I do.
Yeah, and it's because it's an even function, right? Cosine and secant are the only two that are even. And so that's why you can do that, because it's an even function. So, okay, moving on. Your book doesn't have any examples of this, like this kind of stuff, but I was looking ahead at like the tests, and they kind of have some stuff like that. So, all right, what about this? What if they mix up sine and cosine? You cannot use those properties. Sine and arc cosine don't cancel each other out, or arc cosine and sine, if they don't cancel each other out, this would be where you just have to start from the inside and work your way out. This is supposed to be what you did yesterday, the inside part, and then you're just doing like two problems. It's like the thing that's always true. I don't know where it is, but like there's just more than one part to everything we do. Don't touch the outside function until you do the inside function. So step one, tell me what is the inverse cosine of square root 3 over 2? Or what angle has a cosine of square root 3 over 2 in our restricted ranges? Pi over 6. And then you do the outside function. What is the sine of pi over 6? 1 half. So the answer is just whatever you get when you do all of those, but you just have to start with the inside function. So notice on this one, the inside function was inverse trig. On this one, they can switch it. Like, what if they gave you just a regular trig function first? You're going to get the value, and then we'll take the arc sine of whatever that value is. So on this one, what is the cosine of pi thirds? 1 half. And then what is the arc sine of 1 half? Or what angle has a sine of 1 half in our restricted negative pi halves and pi halves? pi 6. So notice that depending on what function is on the outside will determine if you have an angle answer or a value answer. If inverse is on the outside, your answer will be an angle. If it's a regular trig function, your answer will be the value. So maybe not. Maybe I don't have one like that. What if I had sine of arc cosine of 2.7? What angle has a cosine of 2.7? Can cosine ever be 2.7? It's the biggest cosine can be. So that's an example that's undefined. If you do that on your calculator, if you do inverse sine or inverse cosine of something bigger than 1 or smaller than -1, it will say domain error because your domain is stuck between -1 and 1. So that's the example where it doesn't work. If they go outside the domain. Okay. What else can we do? We can make you find algebraic expressions with X stuff, which is super cool. Good old SOHCAHTOA. So it says, find an algebraic expression equivalent to the given expression. Kind of like what we just did, only instead of talking about the unit circle, we're just going to talk about drawing a triangle. And we're going to talk about in terms of X first, and then we'll do some with actual numbers. But again, start with the inside first. Forget about this tangent for a minute and think about what this is saying. Although it's an X, is this the same as saying the sine of some angle I don't know equals X? Like if this said arcsine of 1/2, you'd say the sine of some angle equals 1/2. It just equals X. I don't know what theta is, I don't know what X is, but I can draw a triangle relating these values. So I already drew one for you here. Doesn't matter which angle you pick, as long as it's a cute one. I'm just going to call this theta. Could I label this triangle based on the fact that I know this equals X? Because sine is opposite over hypotenuse. So could I say this side is X, this side is 1? Again, I don't know what X is, but I could find the third side of the triangle in terms of the other two sides. Right? If this was like 3, that wouldn't be 3 because that's 1. But if this was a number, you could actually find the actual length of the side. But we're just going to find an algebraic expression. So I'm just going to do Pythagorean theorem. I do this in my head most of the time, but you can actually work it out. This would be like saying 1 squared equals x squared plus, I don't know what this side is. Don't call it x. I'm going to call it b squared. It's always going to end up a square root because you have to square root both sides. And if you know the hypotenuse in one leg, doesn't it make sense? I'm going to subtract that x squared over, and then I'm going to take the square root, so that's going to be the square root of 1 minus x squared. We're not even done yet, because all we did was kind of draw a triangle based on the inside part. And just like we did on the last one, now we want to evaluate the outside function. I don't know what this is, but it's equal to whatever theta is. Do you agree with me on that? Like arcsine of x is equal to whatever angle has that value, so I just call it theta. Using our triangle, can you tell me what the ratio for tangent of that angle would be? Tangent is opposite over hypotenuse, x over the square root of 1 minus x squared. And you can just leave it like that. So find an algebraic expression means rewrite it without trig, right? Like you're going to rewrite it using x. I need to do it last year. You don't have to rationalize it on here. What I found on your tests and quizzes for this section, they like to do these more with numbers than with x's, but if you get the x's stuff, then we can do the number stuff, which I did, I think, at the end of this. But I think I have one more of these. Let's do one more of these, and then we'll throw some numbers at these. Step 1, draw a triangle. I can draw a triangle for you this time. I'm going to put my theta over here. It doesn't really matter where you put theta as long as you draw it correctly, like label the sides based on your theta. And if it helps you rewrite this, right? Like what is this saying? This is like saying the sine of some angle equals 2x. It could give you cosine or tangent there, it doesn't matter. You could label it either way. But this one's also sine. So sine is opposite, and since there's nothing on the bottom, that means the denominator, the hypotenuse would be 1. The mistake that sometimes people make is they forget to square the 2. They just tell me that 2x squared is 2x squared. But really, if we square that, that would be 4x squared, right? And if we're solving for this side, I always know, if we're solving for this side, it doesn't make sense or not, we're going to take this squared minus this squared. So that's going to be 1 minus 4x squared and the square root of that. I did taught this in pre-calc, whatever day I had to miss. Whenever I missed. Why did I miss school? My kid was sick? Probably my kid was sick. That's why I always miss school. A week or so ago, a couple weeks ago. Oh yeah, it's strep throat. I remember. I recorded notes over this, and the next day when I came in, they said, how do you know whether you subtract under the radical or you add under the radical? And I said, I don't know what you mean. And they're like, well, sometimes the examples, like your radical had a minus, and sometimes it had a plus. And I said, oh, it's just Pythagorean theorem, right? If you're solving for one leg of the triangle, you're always going to have to subtract that over. But what if you're solving for the hypotenuse? Like if this was 1 and this was 2x, and you're solving for this, doesn't it make sense that that's going to equal the square root of this plus this? So that would be 1 plus 4x squared. And so I was very confused by their question because they were wanting to just a shortcut. Like, how do I know when to add and how do I know when to subtract? And I said, oh, it's just Pythagorean theorem. But that is the shortcut. If you're solving for the hypotenuse, you would always add. If you know the hypotenuse and you're solving for one leg, it's always subtracting. So, just in case you're wondering. What do I do now? Yeah, find the cosine now of that angle. And so the cosine is going to be that side we found over 1. We would never leave our answer like that, right? I would just write it as the square root of 1 minus 4x squared. I like the ones with x's better because I don't actually have to do the math, right? There's no complications. Your Ivy Tech tests seem to like the ones with the numbers. It's the same idea though. If they give you something with an x in it or not from the unit circle, then you can just draw a triangle. And so let's look at the next ones. It says evaluate the cotangent of inverse sine of 2 over 7. 2 over 7 is not in our unit circle. And even if you're allowed to use a calculator, they say find the exact answer. And if you type that in your calculator, it's going to not be very pretty. So they want you to draw a triangle. So just like we did with the x's, could I draw a triangle and say the sine would mean this side is 2 and this side is 7? Want to see where I'm getting that? Because inverse sine of 2/7 means what angle has a sine of 2/7? And so now instead of having a square root with an x in it, we can actually find that third side. It might not be a pretty number, but we can actually find that third side. So what would that be? That would end up being like this side squared would equal 49 minus 4, or 45. Square root of 45 would be 3 radical 5. Bear with me on that. I do want you breaking up your square roots. You don't have to rationalize, but you need to break them up. And then what am I going to do? And now you do the outside function. So the inside function helps you draw your picture. The outside function tells you what to evaluate. So cotangent of that angle, cotangent would be what? X over y, or adjacent over hypotenuse. So 3 radical 5 over 2 would be my answer. negative inverse tangent. And you might say, well, how do I know where I am? Because all I know is tangent's negative. Tangent can be negative in quadrant 3 or quadrant 4, normally. But what about inverse tangent? Where is inverse tangent restricted between? Pi halves and negative pi halves. So if I'm going from pi halves to negative pi halves and tangent's negative, where do I have to be? Quadrant 4. Does that make sense? So you still have to know those restricted domains and ranges if they give you a negative. If they give you a positive, it's always going to be in quadrant 1. But for sine and tangent, if they give you a negative, it's going to be down here in quadrant 4. If they give you a negative inverse cosine, cosine is stuck between 0 and pi, so that would be over here in quadrant 2. And so that's the part you need to pay attention to. So on this one, tangent, if this is my theta, tangent is opposite, so that's negative 3. This is 5. So that's how I know that the x would be positive and not negative, is because in quadrant 4, the x value would be positive. I don't know, because I was doing sine. I know, I'm with you. I saw the confusion on your faces. This is what I hate about getting evaluated, because Mr. Puckett wants me to like check for understanding in terms of like make you like give me a thumbs up or a thumbs down or make you use the clickers. But my check for understanding is just looking at your faces, and I was like, okay, something's wrong. Like that's it. That's all I need. I don't need to be like thumbs up if you understand, thumbs down if you don't. Yeah, that would be better if I was a 5 there. It would have been so much better if I was here, though, because then it would have been our favorite 3, 4, 5 triangle, right? That's what I was hoping for. Did I do that right then? That's right. Opposite adjacent. So what does this work out to be? R would be 25 plus 9. 34. Square root of 34. Then what am I going to do? The cosine of that would be my answer. And so the cosine of that would be 5 over the square root of 34, which again, it seems like your book leaves that, but then in the last section they didn't. If you rationalize that, all you do is multiply the top and the bottom by the square root of 34. So those are the same answer. So it doesn't matter which one of those you give me as long as you give it to me. But it's important that you know that the x value would be positive on that. That's the kind of stuff you're going to see more than what we did yesterday over the inverse trig stuff on your test. So this is it for chapter 7. So our unit, or our second test, will be next week. I picked these problems for you to do. As you can probably guess, there's more than just 5 problems there, because that's how this book rolls. It's not my problem. That's just how the book is written. Well, I know, but they all have multiple parts, except for the proofs. So